factor it. You have to find the greatest common factor. Like, can't you take 2 out of 2, 28, and 96? And then out of k cubed, k squared, and k to the first power, what is the greatest common factor of those? Okay, if you're only able to take an equal amount out of each, how many k's can you take out? Just one of those k's. Because this one only has one. Now, that is your greatest common factor that you're factoring out of the trinomial. To figure out what you're leaving, you divide each term by the GCF of 2k. Okay, what is 2k cubed divided by 2k to the first? K squared. Because look, the 2 divided by 2 is just 1. Well, you could write a 1 there, but it's not necessary. Whenever you're dividing variables that are the same, you subtract their exponents. 3 minus 1 is 2. Okay, what is negative 28k squared divided by 2k to the first? What kind? Right, negative 14k. Because negative 28 divided by 2 is where the negative 14 comes from. 96, we're not there yet. K squared divided by k to the first is k to the first, because 2 minus 1 is 1, and you don't have to write it. What's 96k divided by 2k? Positive 48. Now that we have that, could you continue factoring more? By what method? Well, we wouldn't want to distribute, we just took it out. We're undistributing. Couldn't we bubble method that by looking for two numbers that multiply to 48 and add to negative 14? What numbers multiply or add up to negative 14 and multiply to positive 48? Okay, let me show you how the calculator can become your best friend on this test. If you graph that original trinomial that they gave you, okay, but instead of k, so I'm just going to type in x's. 2x cubed minus 28x squared plus 96x. Okay, watch it graph. It just hit there, there, and there. Where are those locations? 0, 6, and 8. Okay, so the x-intercepts for this degree 3 trinomial are 0, 6, and 8. That should help you with your factors. 6 times 8 is 48, right? Is 6 plus 8 14? But we need it to be negative 14. So don't both of them need to be negative? And it's okay if they're both negative when you multiply, because a negative times a negative is a positive. So we write it in here as k minus 6, k minus 8. Remember, on the graphing calculator, it crossed at positive 6 and positive 8. But when you write them as factors, you always write the opposite sign. Now this is why. Let's talk about why you write them as the opposite sign. If you take the 2k, the k minus 6, and the k minus 8, which are the three factors of this trinomial, and you set all three of them to 0. To solve this one for k, what would you do to both sides? Divide by 2, correct? It'll cancel. Divide this by 2. So in that scenario, k equals 0, which was one of the x-intercepts. To solve this one for k, what would you do to both sides? Add 6, and so you would get k equals 6, which was our second x-intercept. And to solve this one for k, what would you do to both sides? Add 8, and you would get k equals 8, which is that x-intercept. So is it starting to make sense to you why, when you look at it on the calculator screen, it's 0, positive 6, and positive 8, but when you have to write it as factors, you put the opposite sign? Does Does that make sense to you? Because when you solve it, like we have to add that over to get a positive 6 and add that over to get a positive 8. So like if you had no idea how to do this, you could just look at your calculator where it crosses and look at your 4 choices and pretty much know the answer. Okay? Alright, next problem. How would you factor something like that? Well, we can't take out an x because this one doesn't have one. So this one can't be GCF. What other methods of factoring have we learned? Yes? Right, bubble method. Where you have x in each one, but what are we doing here? What's this method called? Bubble method. And what do we do when we're doing the bubble method? We just did it in the previous problem. Right, they have two numbers that add up to -5 and multiply to +6. What are some numbers that multiply to 6? Not 6. 5 times 1 is 5. Okay, let's look at 3 and 2. Okay, 3 times 2 is 6. Is 3 plus 2 -5? So what do we need to do? Make them both negative. And now it'll work. So now in here we put x minus 3, x minus 2. So if we were to have graphed this originally, where would it have crossed the x-axis? Positive 3 and positive 2. Let's look. Y equals x squared. Oops, that's not x squared. X squared minus 5x plus 6. It crosses right here at 2 and right here at 3. But remember, they're positive on the graph. Okay, a positive 2x is your x-intercept and a positive 3 is your other x-intercept. But anytime you're taking your x-intercepts from the graph and writing them as factors, you use the opposite sign. Because if you were to take both of those factors and set them equal to 0, you would add the 3 over, and that's how you would end up with it crossing the graph of positive 3. You would add the 2 over, and that's why it would cross the graph of positive 2. Everybody understanding? Okay, next question. Solve each equation with the quadratic formula. I'm going to give you the formula on a formula sheet, so you won't have to worry about memorizing it. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, before we can actually use that formula, we need our trinomial where everything's on one side and it's set equal to 0. So how do I do that? Right, the 75 needs to move over here with everything else, and since it's positive over here, I need to subtract it to get it over here. So now I have 6b squared minus 7b minus 75 equals 0. Now that I have it in standard form, what is my a? What is my b? And what is my c? Okay, so I'm ready to put, I'm just going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. I would do these parentheses on the test just like I'm doing them here. I promise it'll be safer and you won't make a mistake if you put parentheses for every number you're about to plug in. Okay, so what do I plug in for both of these b places? -7. We'll simplify in a minute. Both of these become a -7. What do I plug in for both of these a's? 6. And what do I plug in for this c? Okay, so now like y'all were saying, yes, now we can make this -7 a +7. We could go ahead and make this denominator a 12. Now we can just type it all in. So go to the calculator. Okay, this is a fraction, so I want to set up a fraction on my calculator. How do I do that? Alpha y equals, and Okay, so in the numerator, I have 7. There's no way to type in a plus and a minus at the same time, so you have to do them one at a time. First time I'll use plus, so 7 plus the square root of, you have to type in the parentheses or it will be wrong, parenthesis, negative 7 squared minus 4. At this part, the parentheses aren't as important, but I would just stay in the habit of typing them in. Like you could have put times 6 times negative 75 instead of parentheses, but I would just stay in the habit of using parentheses. Because if you don't have parentheses around that negative 7, it's going to throw everything off. And then times negative 75, and then the denominator is 12. Okay, and the answer is 25 over 6. How do you change that to a decimal just in case your choices aren't fractions? Math, decimal, number 2. Or if you don't think you can remember that, look, you could just type in 25 divided by 6 equals. You get the same thing. I'll round that to 4.17. But that's only one of my solutions. I should have 2 solutions because this is degree 2. And I haven't, all the other problems we've been doing so far, haven't we got the amount of solutions that the highest exponent was? Like on question number 1, it was degree 3, didn't we get 3 answers? And then question number 2 was degree 2, we got 2 different answers. So we need to get 2 answers here. How am I going to get that second answer? Plug it in with the minus. Now, instead of taking the time to type it all back in, if you will just go up to it till it highlights what you typed in, and then hit enter, it'll copy it down here, and now you can just go over until you get to that, which is hard to see because all my writing on there. Oops. I'll erase a little bit we don't need anymore. Okay, so you just keep going over until you get to that first plus sign and change it to a minus. And then hit enter, and there's your second answer, negative 3. Now, let me show you something that will be way easier, especially since it'll be multiple choice. If you can at least remember to subtract the 75 over so that everything's on the same side, then you can graph this, just like we've been doing with all the other problems. If you go to y equals, and you graph 6x squared minus 7x minus 75, look what happens. It's degree 2, so it's going to cross in 2 places. In this one, negative 3. In this one, a teeny past 4, which is why it's 4.17. So with multiple choice, don't you think you could just graph it and know the right answer? Okay, question number 4. Why don't y'all take a minute and just see what you can do with that one? Okay, so yes, you could use the quadratic formula like they say. You would start by moving this to this side by subtracting it. So it would be 4b squared minus 121 equals 0. Then you would have to identify the a, b, and c in order to use the formula. Remember, all trinomials are in the form ax squared plus bx plus c, or in this case, ab squared plus bb plus c. So what is the a? 4. A is always the one with the square term. What's the b? Right, it's the one that's missing. The regular number, which is your constant, is always c. So that's negative 121. Then you would have plugged it in, negative 0 plus or minus the square root of b squared, which would have been 0 squared, minus 4 times negative 121, all over 2 times a, which would have been 8. then at that point you would have typed in the discriminant. What is 0 squared minus 4 times negative 121? Nobody has it yet? When you type in 0 minus 4 times negative 121, you should get 1,936. Then at that point, you could actually type in the square root of 1,936. So type that in, square root of 1,936. Right, so that becomes 44. Okay, so now we don't really have to worry about this anymore. We can just kind of ignore that. And we have plus or minus 44 over 8. Well, what is positive 44 over 8? 5.5. What is negative 44 over 8? Right, so those are your two solutions. Now, another method would have been the square root method. You could have started by dividing by 4 on both sides. You would have ended up with v squared equals what? What is 121 divided by 4? 30.25, right. Now to get v by itself, what would you then do? How do you get that squared away from the v? How do you undo when something's squared? How do you undo it? You square root it. Okay, then you square root this side. Okay, so the square root cancels out the squared, leaving v by itself. Anytime you are solving for a variable and you have to square root, you put plus or minus on your answer. What is the square root of 30.25? 5.5, which isn't that what we got? Or a third method, once you had rearranged it into standard form, you could have graphed it. Okay, so let me show you what it would have looked like. Y equals 4x squared minus 121. It crosses 2 times because it's degree 2 at negative 5.5 and positive 5.5. Okay, so really that would be the easiest. Well, if you hit second trace, we're looking for the x-intercepts, which is also known as zeros. You can hit 0, but then you got to do the left bound, right bound, so like you have to click it till you find the cursor. It must be like way down here somewhere, so it's coming up. See, there it is. I went a little far. But anyway, once it's on the left side, which it is now, you could hit enter, and then you would come down. See how I put a line on the left side of that 0? And then you come back down until you're on the right side of it and hit enter. And then you hit enter one more time and it says negative 5.5. And then you could have done the same thing over there, second trace 0. But really with multiple choice, you can pretty much, if you see negative 5.5 and 5.5, you'll know that's right. Okay, number 5. Solve each equation. Remember to check for extraneous solutions. Okay, so anytime it says solve an equation and there's an x, what do we need to do? Okay, get x by itself. So that means get the 17 away from it, get the minus 4 away from it, and get the square root away from it. What needs to go first? But right now, the 17 and the 4 are trapped because they're up under that square root. Right. You square this side, which means you have to square this side. Now, on this side, they cancel each other out like we wanted, leaving 17x minus 4. but on this side you get a 64. Now you just have a two-step equation. What do you do first? Add the 4, and you get 68 equals 17x, and now the last remaining step to get x by itself is divide by 17, and so x equals 4. Now you do have to check to make sure that it's not an extraneous solution, which means plug it in, see if it really works. If I plug in a 4 right here, what's 17 times 4? What's 68 minus 4? So you basically end up with a 64. What's the square root of 64? 8. So it really works. So that really is a true solution. If it hadn't worked, that's what we call an extraneous solution. Okay, tomorrow we will continue working on this. 6, 7, 8, 9, and 10 are part of 4B. 11 through 20 are all Unit 5. It is in your best interest to go home and try to work through at least problem 20, because if you just come in and wait for me to do it and then you copy it down, you're not learning near as much as if you go home tonight, get out your Unit 4B packet and your Unit 5 packet and see what you can remember yourself. When you start looking at problems in the packet that you've done, things will come back to your mind. Okay, so I would at least attempt to work them by yourself, and then tomorrow we'll go over them so you can see what you got right and what you still need to work on. Also, the video will be on the blog of these 5 in case you feel like you need to go back and watch any of these.